In this video, I'll be using Claude Code and OpenCode to compare DeepSeek 4 Pro Max, which sounds like a new iPhone, Kimi K2.6, and Qwen 3.7 Max, with a bit of MIMO 2.5. I will also use Claude Opus 4.7 Extra High to judge some of the work, so that the comparison is not only based on my code review. The first task is a UI alignment issue in a football matches page. The odds buttons are misaligned when matches belong to different tournaments, so the model needs to understand how different components work together, rather than just changing one CSS value. I started in OpenCode with Kimi 2.6 and DeepSeek 4 Pro Max in separate work trees, so I could compare them side by side. DeepSeek 4 Pro Max is extremely cheap, but it uses a lot of tokens and takes too long to get the work done. That matters when choosing a language model. I would consider it more useful for long-running overnight jobs than for fast interactive coding. Kimi 2.6 is a very capable model. On the Artificial Analysis Intelligence Index, it ranks highly among both open and closed models. I used Kimi 2.6 through OpenRouter, while I used DeepSeek 4 Pro Max directly from DeepSeek. That's so that I did not use a provider which offered a degraded DeepSeek model, as some do. DeepSeek 4 Pro Max had better tokens per second performance than some previous DeepSeek versions, partly because there are now more providers serving the API. Kimi 2.6 was also fast in this test, and I was especially impressed by its prompt caching. However, Kimi 2.6 did something surprising. It stopped all node processes, which caused OpenCode to stop as well. That should not happen. It might be possible to prevent that with an explicit prompt, but I do not want to spoon-feed a model in 2026. When I checked the actual result, Kimi 2.6 did not fix the odds button alignment issue. DeepSeek 4 Pro Max also left the buttons misaligned. So for the first task, both Kimi 2.6 and DeepSeek 4 Pro Max failed. Looking again at the Artificial Analysis Intelligence Index, MIMO 2.5 Pro is also listed, but I limited testing it because it could not handle images and crashed inside OpenCode. Kimi 2.6 has a 256,000 context window, which might limit it on long-running tasks compared with models that offer a 1 million token context window. That is probably worth a separate agent video. I also tested the OpenCode native app. It is coming along, but it still does not feel refined. For example, I did not find a good way to use multiple tabs the way I do in the terminal. That is surprising because some of its counterparts, such as Codex and Claude Code, are already quite good in that area. Before this recording, I tested MIMO 2.5 Pro against Qwen 3.6 Max Preview. Before MIMO hit the image issue, both models looked capable, but Qwen 3.6 Max Preview stood out. Qwen 3.7 Max has been released since then, but it has issues with prompt caching and token usage. I will come back to that because prompt caching can make a large difference to cost. When I checked the Qwen 3.6 Max Preview output, it had completed the alignment task, which was excellent. MIMO could not produce the required image result, so for the next test, I moved to Qwen 3.7 Max against Kimi 2.6. For the mythos/security style test, Qwen 3.7 Max used a lot of tokens because prompt caching was not working properly. Kimi 2.6 has another issue. I would not recommend using it during live streams unless you add extra instructions, because it can print secrets while it works. I have seen other models, such as GPT 5.5, avoid doing that. Qwen 3.7 Max produced useful security feedback. It pointed out an admin bypass that I had forgotten to remove, although that issue had already been removed in a pull request. It also mentioned endpoints where data could be injected and commented out authorization, which were valid findings. It also mentioned payment subscriptions, which surprised me because that part is not currently working. Qwen used almost all of my OpenRouter credits, so please subscribe to the channel so I can keep making these comparisons. In OpenRouter's Activity tab, Qwen 3.6 Max Preview used almost all the credits with a similar token count. I wanted to know whether it was just an expensive model or whether caching was the problem. In the logs, the icon next to the cost shows whether a request hit the cache. I noticed that Qwen was often not hitting cache even when it was using Alibaba Cloud. On the OpenRouter model page, the provider list shows cache creation and cache read details. For some providers, the cache hit rate is very low. My tip is to note those providers, go to Privacy, then Ignored Providers, and add providers with a 0 cache hit rate. I wish OpenRouter allowed us to automatically ignore providers below a chosen cache hit threshold. Artificial analysis also shows cache hit rate by agent. Claude Code looks like the best overall for cache hit rate. I am not sure exactly how they got that working. OpenRouter may have optimized for Claude Code more than for OpenCode with the same models. The next task was on my LearnRacer website at learnracer.com. The homepage scrolling was slow, so I set up Kimi 2.6 and Qwen 3.7 Max in Claude Code and asked both of them to improve the homepage performance. Qwen 3.7 appeared faster than Kimi 2.6, but that was mostly because of provider speed. Kimi 2.6 seemed to hit a bug where it got stuck. I still had tokens available, and Qwen 3.7 kept progressing, but Kimi would not continue even after I asked it several times. To make non-anthropic models work with Claude Code, I used the Claude Code router. It is available on GitHub and has more than 35,000 stars. If you use it, give that repository a star. After both models had worked in separate work trees, I gave the two implementations to Claude Opus 4.7 Extra High and asked it to judge them. It analyzed both implementations and produced a useful comparison table. On the LearnRacer performance task, Qwen 3.7 attacked the actual bottleneck. Kimi 2.6 did not. There were other criteria such as re-render reduction, where Kimi did better in some areas and Qwen did better in others. However, Qwen introduced a regression that made the task fail outright, and it also pushed changes even though I did not instruct it to push. Because of that, I gave this task to Kimi 2.6. You can try LearnRacer yourself at learnracer.com. Choose your profession, select your seniority level. At the end, here is how I rank the models. For DeepSeek 4 Pro Max, I would not give it points for performance, but I would give it points for cost. It is cheap, but it is slow and token heavy. For Qwen 3.7, I give it points for overall software engineering and for the mythos/security style test. I have to give it negatives for cost because the prompt caching issue made it expensive. In that form, the cost can become unusable. MIMO failed the image-related work, but it gets a plus for cost. Qwen 3.6 Max Preview passed the earlier task, while GPT 5.5 should probably be excluded from this specific comparison because it needs its own context. Kimi 2.6 loses points for the smaller context window because the other models are closer to 1 million tokens, but it gains points for cost and for winning the LearnRacer performance task after Qwen introduced a regression. Overall, I am impressed with Qwen 3.7. It just needs the cost and prompt caching problem fixed. Kimi 2.6 ends with a +1. Qwen 3.7 ends with a +2, which makes it the winner for today's tasks. The issue where Qwen 3.7 pushed changes without permission may be in my prompt file, a skill, or an agent skill, so I need to investigate that separately. In future videos, I will compare Composer 2.5 and other agent harnesses. Please subscribe to the channel. This was my real-world coding comparison of Kimi 2.6, DeepSeek 4 Pro Max, and Qwen 3.7 Max.